Hello, this is the section 4.4 lesson. In section 4.3 we talked about the commutative and associative properties of multiplication. Chapter 3 we talked about the commutative and associative properties of addition. In this section we're going to talk about a property that combines both addition and multiplication called the distributive property. And so let's do a simple example that's going to motivate our distributive property. How many dots are in the figure below? Well, there's lots of ways that we could answer this question. One way is to simply count the number of dots. That's easy. Another way to use multiplication is to note that we have 4 rows and there are 7 dots in each row, and so this would be 4 times 7. But let's look at this in a couple of different ways. Let's break these dots up in two different ways. First way, we're gonna group things in rows like this, and then the second way we're going to group things. We're going to kind of put the red dots in one group and then the blue dots in another group. Okay. Now let's look at this first grouping and look at how we can calculate the number of dots using multiplication. Well, here we've got 4 rows, 1, 2, 3, 4, so that's like 4 groups. And then in each one of those groups, or in each of those rows, we have 5 red dots and then 2 blue dots. So the total number of dots there would be 5 plus 2. So there's one expression that gives the number of dots in that figure. Well, let's look at the second way of looking at it. So here in the red dots, we've got 4 rows and 5 columns. So this would be 4 times 5. That's the number of red dots. But then we need to add the number of blue dots. Well, the blue dots, we have 4 rows and 2 columns. So this would be 4 times 2. 4 times 2. So that's the number of blue dots. So we add those together. That's going to give us the total number of dots. So here we have one expression that gives the total number of dots. Here's another expression that gives the total number of dots. And so these two expressions should be equal to each other. So let's kind of summarize what we just saw here. We had this expression that gives the total number of dots, this expression that gives the total number of dots, and so they must be equal. Well, let's look at how we can think of going from one side to the other side. Over here we have a 4 times 5 and a 4 times 2. We can think of this as though we kind of took the 4 times the 5 and then the 4 times the 2. So the 4 times the 5 comes over here, and then the 4 times the 2 comes over here, and we add them together. So we describe this as though we distributed the 4 across that addition. And so this illustrates what we call the distributive property. So here's the distributive property stated in kind of generic terms. Here A, B, and C could be numbers or they could be expressions. And so this says that A times B plus C. In order to do this, we can distribute the A to the B and then the A to the C. So we get A times B, and then we get A times C, and then we add them together. And that's what we call the distributive property. Now there are some slight variations on this. This first variation, we have addition first and then multiplication on the right. And the idea here is basically the same. We take the A times the C and the B times the C. We get A times C plus B times C. In this version here, it's A times the sum of 3 things. But same basic idea. We can distribute the A across that addition. We get A times B, A times C, and then A times D. This last variation is we have subtraction here instead of addition. So again, we can distribute that A across, A times B and A times C, but in this case we're going to subtract rather than add. Now let's look at an application of this idea to a situation where we have the sum of 2 quantities times the sum of 2 other quantities. And so let's distribute this. So what we mean by this is we want to rewrite this. We're not going to do the arithmetic. We're just going to rewrite this using the distributive property. And so here's what we're going to do. We're going to treat this as like one big expression. We're going to distribute that to the 10, and then we're going to distribute that to the 4. And so we're going to have this first expression, 10 plus 3, times 10, and then plus that first expression, 10 plus 3 times 4. So there we have distributed. Okay. Well, now let's distribute again. Notice this expression right here, this big expression, is something that we could apply the distributive property to. Take 10 times 10, 3 times 10, and then likewise over here we can distribute 10 times 4 and 3 times 4. And so what we have here is a 10 times 10 plus a 3 times 10 plus a 10 times 4 plus a 3 times 4. So there we have distributed again. So we've used the distributive property twice in order to rewrite this original expression. Well, let's take a step back and look at what we did here. Let's look at the 10 times 10. Well, the 10 and the 10, those were the first terms in both of those expressions. So here we multiplied the first expressions, or the first terms in each expression. Now, the 3 times 10, well, the 3 and the 10, those are kind of like the numbers that are on the inside. So let's write an I there for inside. Now, the 10 times 4, where did that come from? Well, there we took this 10 here times this 4 here. Well, those are like our outside terms in that expression. So let's write an O there. And then the 3 times 4, where did that come from? Well, here we took the last term in this first expression times the last term in that second expression, and so let's write an L underneath it. So, what does that spell? Well, feel. Well, we often abbreviate that or rewrite this as FOIL, F-O-I-L, first, outer, inner, last. And so here's our FOIL property explained in kind of abstract terms or general terms. We've got A plus B plus C times D. These A, B, C's, and D's could be numbers, they could be expressions. So here we have A times C, A times D, B times C, and then the B times D. And so that's where the FOIL property comes from. It's a repeated application of the distributive property. Well, an explanation for the FOIL property that we just did, where we used the distributive property twice, might be a little bit abstract for some students. So let's look at a way that we can justify the distributive property geometrically. And geometrically, we're going to use ideas from last section where we talked about how we can use multiplication to find the area of a rectangle. So let's take this original expression, 10 plus 3 times 10 plus 4. We can think of that as representing the area of a rectangle. Specifically, that's a rectangle that has a height of 10 plus 3 and then a width of 10 plus 4. So this expression here represents the area of this rectangle, or stated another way, it's the number of these little individual squares that we have here. So we could count the number of squares there, but let's look at how we can find that using multiplication. So let's take this big rectangle here and break this up as 4 smaller rectangles. And so let's find the area of each one of these smaller rectangles. So in this first rectangle, this has 10 rows and 10 columns, so this area is 10 by 10. The second rectangle has 10 rows and 4 columns, and so its area is 10 times 4. And then this rectangle here is 3 by 10, 3 by 10, and then this last one here is going to be 3 times 4. So here's the areas of these 4 smaller rectangles. If we add up all of those 4 rectangles, we're going to get the same area as this big rectangle over here. So let's put this all together. The area on the left here is 10 plus 3 times 10 plus 4. The area of all 4 of these combined is 10 times 10 plus 10 times 4 plus 3 times 10 plus 3 times 4. And so there's 2 different expressions for the same area, and therefore they must be equal. And so again, we see how this illustrates the FOIL property, how we take our first there to get 10 times 10, and then the outer 10 times 4, and then the inner 3 times 10, and then the last 3 times 4. So there's a way of illustrating the FOIL property geometrically. So that's it for the section 4.4 lesson. Your assignment before next class period is to read section 4.4 from the textbook.